Hi guys, here's another video about the CSS Pure Mathematics Exam from 2023. We're in section C, and this is question 7, item A. So it asks us to determine K such that this mapping U given by e to the power 2x times cosine ky is harmonic, and it also asks us to find its conjugate harmonic. So let us proceed through the first part, which is to find K for which the function is harmonic. So we need to find values of K for which this expression here is true for all x and y in the domain of U, which is R2. So this is the definition of a harmonic function defined in R2. It must satisfy this equation for all x and y. So we take the first order partial derivatives of U. Here we have ux, it is 2 to the power times e to the power 2x times cosine ky, and uy equals minus k e to the power 2x times sine of ky. Now we have to take derivatives again. So we take the derivative of ux with respect to x and we get uxx. This is 4 times e to the power 2x times cosine ky, and we take the partial derivative of uy with respect to y, and we get that uyy equals minus k squared times e to the power 2x times cosine ky. Now since we want this expression, we need to add up these two expressions here. So this is what we do here. So we have that uxx plus uyy equals this expression, which we can rewrite as this. So 4 minus k squared times e to the power 2x times cosine ky. And since we want u to be harmonic, we need that this expression is equals 0 for all x and y. So if we want the u to be harmonic, this equation must be satisfied for all x and y. In particular, it must be true for 0, 0. So if we plug 0, 0 in this expression, since e to the power 2 times 0 is 1 and cosine of k times 0 is 1, at the point 0, 0, we must have uxx plus uyy equals 4 minus k squared. And if we want u to be harmonic, this must be 0. So, and 4 minus k squared is 0 if and only if k equals minus 2 or 2. So the only possible values for k which make u harmonic are minus 2 and 2. And indeed, if we take k equals 2 and plug in this expression, we obtain 0. And if we take k equals minus 2 and plug into this expression, we also obtain 0 for all x and y. So the only values for which the function u is harmonic are k equals minus 2 and k equals 2. And the first part is done. Now just recall that the function we had the expression e to the power 2x times cosine ky. Since cosine is an even function, if we plug k equals minus 2 or k equals 2, we obtain the same function because cosine of minus 2y is the same as cosine of 2y. So the harmonic function u we obtain is u of xy equals e to the power 2x times cosine 2y. And this is the function for which we want to find a conjugate harmonic. So let's look for this conjugate harmonic, and first let's recall what we mean by that. So a function v defined on the same domain as u, which is in this case R2, is a conjugate harmonic to u if and only if it satisfies the Cauchy-Riemann equations in R2. So we must have that vy must be equals to ux and vx must be equals to minus uy for all x and y in R2. So let's see how this expression what this expression become in our particular case. So we take the partial derivative of here of u with respect to x. So it's 2 times e to the power 2x times cosine 2y. And if we take the partial derivative of u with respect to y, we get minus 2 e to the power 2x times sine 2y. And since we have a minus here, the minuses cancel out. So we get this expression. So we have these two equations. And if we look, we can look at this expression as a differential equation in the variable y, and we can look at this expression as a differential equation in the variable x. And we are going to solve them by integration. So first, we integrate this expression with respect to x, and we obtain that v of xy equals e to the power 2x times sine of 2y plus a function which only depends on y. And if we can check this, if we differentiate this expression with respect to x, we obtain 2 e to the power 2x times sine 2y. And since this here only depends on y, we get 0. Doing the same thing with the other expression, we integrate this expression with respect to y, and we obtain that v of xy equals e to the power 2x times sine 2y plus a function which only depends on x. So if we differentiate this expression with respect to y, we obtain what we had here, 2 times e to the power 2x times cosine y. And since g of x only depends on x, we get 0. So if we can compare these two expressions, for example, if we take the difference between them, because v is the same function, we would get that fy minus gx equals 0 for all x and all y. So we have two functions, one which only depends on y and other one which only depends on x, and they must be the same. The only possible situation is for them to be a constant function, for both of them to be a constant with the same value. So there must be a constant k for which f of y equals k, which is g of x for all x and y in R2. And now we get, with this, we get all the conjugate harmonic for 2u. But the problem asks us to find just one, so we get the simplest one. We take k equals 0. So if we take k equals 0, we get that v equals e to the power 2x times sine 2y is a conjugate harmonic to u. And we are done. Thank you very much. I hope you enjoyed this video. Please give me a thumbs up, subscribe to the channel, and leave me a comment. Let me know what you think of my videos, and I will post more of them soon. Thank you very much. Bye.